first page together, so I'm not going to go back over that one. I'm going to zoom out a little bit because I don't want to keep scrolling. Okay, so we're on case 2. Okay, so what we want to see here is that we have some value. I chose x, right? So we go x to the line, and with a reflection we go however many we go to the line, we go that many past the line. So we go x to the line, x past the line, and there's a prime. Okay, then we got to reflect it over line 2 right here. So we go y to the line, and we got to go y past the line. So that's where a double prime should have been. So on the side of your screen here, or on the side of your paper, you should have put something like the distance from line 1 to line 2, right, which is right there, is x plus y. Okay? And then the distance from A, which is right way over here, to A double prime is 2x plus 2y. So there should be 1 2x's, 1 2y's. And then, right, 2x plus 2y is double x plus y. So that whole idea that the translation is double the distance of the two reflection lines stays consistent. Okay, good. So this one. Okay, so we're going to have to reflect it, this point A, over line 1. So what I did was I had this little part be x, and then I had this whole section be y. Okay, so we went x plus y to the line, so we got to go x plus y past the line. So this is our A prime. Okay, now that we have this point, we got to reflect it over line 2, which is right here. Okay, so that means that we have to go x plus y to the line, which means we have to go x plus y past the line. Okay? Everybody still following here? Doing okay? Okay, good. So the important part, though, was the distance from A to A double prime. Okay, remember this whole thing from here all the way down is x plus y. But we're starting at a point that's past the x value. You see that? So we're not using this x anymore, so it's just y plus y. So the distance from line 1 to line 2 is y, and the distance from A to A double prime is 2y. Does that make sense? Right? Still holds true. Good. Okay. So now cases 4 and 5 you're supposed to do on a separate sheet. So I did mine right here. So first one I did, I put the A over here, and I had to reflect across the line 1, right, which is this line. And that doesn't change the spot of A at all, right? Since A is on the reflection line, it doesn't move at all. So then I have to now reflect over this line, line 2. So I'm going to say we go x distance this way to the line. Then we got to go x distance past the line. So the distance from line 1 to line 2 is x. And the distance from A to A double prime is x plus x, or 2x. Okay? Last one. Here we go. So start here at A. We're going to reflect over line 1 first. So we're going to go x units to the line, x units past the line. Okay? Then we got to reflect over line 2. So we got to go 2x to the line, 2x past the line, which means the distance from A to A double prime is 2x right there. And the distance from line 1 to line 2 is just x. Does that make sense? Does anybody want to see any of those, or are we feeling okay? Yeah? Perfect. Okay. So now if you'll pull out the note sheet for today, it looks something like this. It's the bolded one. It says proof of composite reflections over intersecting lines. Okay, so here we go. Now this is new, so we want to make sure that we're paying attention, keeping our phones away, all that stuff. All right, here we go. This is not my pen. All right, so first thing I'm going to do is I'm going to draw a line from A to the intersection point. So I just drew this line A all the way to the intersection point. All right? So now, okay, instead of using lengths like we did when they were parallel, we're going to use degrees, okay, for angles. So this angle, we're going to say is x degrees. Can you guys see that in the back, x degrees? Yeah? Okay. So the principle stays the same. We're going to reflect over line 1. So our A prime should be somewhere over here. Okay, I'm going to draw a line from A prime to the center point. Okay, so here we go. So starting at A, we went x degrees to the line. So how many degrees are we going to go past the line? X degrees. Good. So this is x degrees. Okay? Good. So now we've got to reflect over this line 2 right here. So I'm going to call this y degrees. Why, Mr. B? Well, because I wanted to. Get it? Okay, whatever. Fine. Tough crowd, whatever. Okay, so we're going to reflect. Oh, you didn't hear it?
No.
I'll talk louder next time when I say a joke. Okay. All right, so we're going to reflect A prime over this line. So I'm going to put A double prime about right there. Okay. I'm going to draw my line to the intersection point. Now remember, if your points aren't exactly reflected, if they aren't exactly the same length, that's okay. Right? We're working in generalities right now. So it's okay that it's not exact. Okay? So remember, we went y degrees to the line. So how many degrees do you have to go past the line? Y degrees. Okay? So we have this pretty little picture here. Now we got to do some words. So what I would say is degree distance of line 1 to where? Right here? This one? Because remember, we went from A prime, we went y distance that way, so we got to go y distance past the line. Remember that? Kind of like the reflections? Right. So whatever, again, just like on the parallel lines, we went, like x towards the line, we have to go x past the line, that kind of thing. That kind of makes sense? Okay. So again, you could use, you could swap these with y's or x's or a's or b's. It doesn't matter what the variable is, just that these two are going to be the same and these two are going to be the same. Okay? Okay. So good. So distance from line 1 to line 2. We're looking for the degrees. So what's the degrees from line 1 to line 2 here? X plus y. Good. X plus y, and I'm going to put a little degree sign there. Okay? So then we've got to go degree distance of A to A double prime. Okay, so A is all the way up here, and A double prime is all the way down here. So how many percent? 2x plus 2y, right? But yes, right. So 2x plus 2y. So this should be 2x plus 2y degrees. And right, if you look, right, this is double what this one is. Yeah. Yep. So another way that you could write this is 2x plus y. That's another way to write it. It's all the same thing. Do we have any burning questions about this that we just really don't understand? Yeah?
I understand, but I just have a question.
Okay.
With the next two problems, are we making the A line to the center every single time?
I would.
Okay.
Right? Because look, if you don't make the A line, then you're kind of like almost guessing where your degree thing is going to be.
Okay.
So if you draw that line, then you know, oh, okay, that's where it ends or whatever. Olivia? That's a good question. So basically the reason is that this one is closer, and so it's being applied first. And then this one gets applied second. Now, I know that like when you're reading it, it looks like you should go left to right. But in this case, we go right to left because this one's closer, right? Yeah. Unfortunately, that's the best reasoning I have for you. Yeah. Because actually, we're the weird ones. A lot of cultures like right to left. Yeah, like they read right to left, which is cool. But anyway, interesting fact. But anyway,